Hello, my name is Paul Thomas Edward Cusick. Prepared a talk on physical economics. I'm an engineer by education, and I'm applying engineering principles to economics, which I studied pretty thoroughly. And some people call physical economics econophysics, but I'm calling it physical economics. It's where you use equations from basic physics to solve economic problems. In the same way that there are fundamental forces in nature, gravity, nuclear, and electromagnetic, the same appear in economics. In the same way that we use these macro forces, cosmological, can be reduced to quantum forces, the wave equation. Economics, too, has the same equation. This paper provides the calculations that lead to the fundamental solution of economics. So we have the interest formula, I plus 1 plus I is the interest rate to the power n is the number of periods. And then 1 plus the resistance to mass formation to the power pi, which we'll see in the following graph. Next slide. Rm is resistance to mass formation, or the cost of money, I, capital I. Pi is equal to the time, and E is equal to the energy, which is equal to the gross domestic product. So we take the sum of the inputs, interest, and material labor, which sum to the gross domestic product of energy, E to the power minus T equals resistance to mass plus ln of E for money. There's the graph. We see the logarithmic function right here, and there is material and labor is equal to the mass, which is equal to ln of T, and your time is equal to pi from 1 to pi. So the universe exists starting at this point right here where the ln function crosses the x-axis at 1. Then the gross domestic product is E, and it's equal to e to the power minus t, exponential function. And right here is the critical point when t equals pi. So we let the position L, the distance L, equal to the velocity. L is the position and V is the velocity in quantum mechanics. We take the integral of both sides. We end up with the money supply, Ms is equal to the L times the integral of L, which is equal to L times the money supply, which equals L, which is equal to V times the supply, money supply, which is equal to 7, which is equal to 10 divided by the square root of 2. That's 7.07 is equal to T minus E plus the ln of E. 8.07 E equals the ln of E. E is equal to 0.868. And 0.868 is approximately equal to 1 over the sine of T, or sine of 60 degrees, 0.866, which is a well-known equation from astrotheology. So we have in astrotheology two important considerations. We have the superforce, and we have the grand unified theory. And the money supply is equal to the sine of theta, which is equal to force, because energy is equal to 1 over the force. So 1 over the sine of 60 degrees, as we've just shown, is equal to 1 over the force. Force is equal to ma from Newton, which is equal to momentum, which equals mb, because A equals V. They're equal to the superforce, which is equal to F equal to 8/3, which is 2.667. The money supply divided by the individual's money is equal to ms over Im, which is equal to sine theta times m. So we have 8.3 is equal to sine theta m to the power 2. 8/3 is equal to 0.8415 times m squared. M is equal to pi, which is equal to t. So mass is equal to time. We have the individual's money, IM, is equal to pi to the power 2, pi squared, which is equal to 1.7802 times pi to the power 2 divided by 1.151, which is equal to 1.7802 divided by 1.15, which is equal to 1.548, approximately equal to the mass gap, 1.5, where the mass gap is equal to 1 over g, where g is equal to 2/3, gravitational constant. So an expression in business is it takes money to make money. The more money accumulates, the more money one has to invest and make more money. It's the same with mass or matter. The more mass there is, the greater the pull of gravity. So money is like gravity in that sense. But gravity works the same for all money as it does for matter. F is equal to 8/3 equals ma equals mv. Force equals momentum. A equals v equals 0.8415. And mass is equal to F over A, which equals 8/3 divided by 0.8415 equals 3.16 equals pi equals t. Mass is equal to T times dm by dt, which is equal to dt by dt equals 1. The integral of dm by dt is equal to m, which is equal to 1 over e, which is equal to 1 over t, equals 1 over 1 equals 1, which is 100% the world's GDP. The economy is always seeking to find this optimum condition. When individuals seek to save 15% or 1/7 of their economy, the economic multiplier, which is used for investment, the economy is functioning, as they say, on all cylinders. It creates an economic situation where the velocity of money is equal to the supply. So we have also in natural theology the golden mean parabola, t squared minus t minus 1 equals potential energy or energy, which is equal to e to the power minus t. So if we plug t as ln t in the equation, we have 2 ln t minus 0 equals minus t ln t, which is equal to minus t times 1 over t, which is equal to 1 over t equals 1. 1/2 times e times t times s's position is equal to 1/2 times 0.868 times 1 times s, which is 4/3, which is equal to 1 over the square root of 3. So square root of 3 is the eigenvector, we know from natural theology. So 1 over the eigenvector, which is time, is equal to energy. Schrodinger's wave equation governs atoms and individuals in an economy. So atoms in physics is the same as individuals in an economy. And U is equal to I plus V, I times V, which is equal to 1 plus 1 times the value of V is minus 0.618, is equal to 1.618. So 1.618 equals 1 divided by the square root of 2 pi times e to the power k times, and k is equal to 0, or is equal to 14.001. Now e plus 1 plus e to the power t is equal to the eigenvector, which we saw up here, and e to the power t is equal to 0.73 ln with 0.15 t is equal to ln of 0.73 times 1.5 t equals 3.14, t equals 2.098, which is equal to 2.1 ln t times ln of 2.15 equals 3.069, which is approximately equal to c, the speed of light. ln of t is equal to t times 1 over t, which is equal to 1 equals t times e, which equals t. So my next paper in this series, I think there's 6 papers altogether. The next one, the second one, is Cusick's U.S. economy equation. So we develop an equation for the U.S. economy based on past performance. So this paper uses 11 variables in one equation that describes the U.S. economy. It can be used to predict the peaks to crash and where we are in the economic cycle. So continuing with the U.S. economy equation, we have the gross domestic product is equal to the exponential function e to the power x. So we use 8 different indicators, economic indicators, based on the fact of what their underlying function is. For example, we take unemployment here. The unemployment is a sine function, or personal income is linear, for example. So we use Standard & Poor's 500 index, we use the Consumer Price Index, unemployment, commodities index, oil, gold production, new residential construction, personal income, global stock market. Each one of these indicates is a sine, cosine, or exponential function. So y is equal to y prime. That comes out of astrotheology. Function is equal to the derivative. Y is equal to e to the power x. Y equals y prime. Y equals sine of x plus the first constant equals cosine of x plus the second constant. X is equal to 1, y is equal to 0.8415, and that's pretty close to 0.86. Boundary condition, we let x equal 1, C3, third constant, is equal to 1.8768. Y is equal to e to the power x minus 1.8768. Fourier series, we have y is equal to e to the power x minus 1.8768. Y is equal to a sine x plus b cos x. A sine x plus b cos x equals e to the x minus 1.8768. A times 0.86 plus b times 0.86 equals 0.8415. A plus b equals 1. A is equal to 1 minus b. So 1 minus b sine x plus b cos x is equal to e to the power 1.8768. 0.86 minus b 0.86 minus b 0.86 is equal to e to the power 1 minus 1.8768. Y is equal to e to the power 1 minus 1.8768. Y is equal to 0.8415. That's an important number. For a full cycle, 1/2 of pi is equal to 0.1592. 0.1592 is the moment. It's equal to 1 minus the sine of 1. So 0.1592x is equal to 6.28x. which is equal to 39.467. So from peak to trough, there are 78.93 years. That's a critical number, about 79 years. So if you go from October 9th, 1929, the crash, then add that value of 78.93, you got 2007.9, which is November 4th, 2007 peak to crash. That's when the market crashed. So there we just, I won't read all that, but it's it was produced by Mathematica when I put the data into to develop an equation. That was the equation that came out. So I won't read all that off, but it's just your U.S. economy equation. So y is equal to e to the power 1 minus 1.876. Y is equal to 0.84. But we know from the dampened cosine that y is equal to 0.202. So y is equal to e to the power 1315. That is the U.S. economy equation. And that is equal to 1.145. 1405 is your economic multiplier. So the conclusion we draw from this section is that y is equal to y prime. The economy or the function is equal to the derivative, which we know by now from astrotheology. So this next paper is called the macroeconomic model, stiffness in the GDP. The abstract for this part is continuing with the theme of physical economics presented in the previous papers. We develop a solution from the stiffness equation from structural engineering, a branch of civil engineering, that allows us to calculate the GDP growth for a broad economy. It is important because the solution can be programmed into a computer language to solve for the critical variables that need to be determined to manage the economy. Knowledge of astrotheology mathematics is helpful in understanding where some of the variables come from and why the golden green parabola is particularly important. Physical economics, or some people call it econophysics. I like physical economics because it's similar to macroeconomics, microeconomics, labor economics, environmental economics. So we got physical economics. Makes use of readily available solutions to structural engineering problems that can be applied in the solution to the parameters of the broad economy. The stiffness equation from matrix structural analysis is used in this presentation to link the supply curve and the demand to the GDP growth. The key factor is K, the stiffness coefficient of the structure of the economy. This mathematics, which I call astrotheology math, or AT math for short, is the solution to cosmology as well as economics. The dampened cosine is used to model the trajectory for an economic project, such as the wooden shipbuilding production in the 19th century St. John in Canada. The distance differential equation from basic physics is used to solve for stiffness, K, as well. This is all linked together by the golden mean parabola, which plots GDP versus stiffness. We begin with the stiffness equation matrix. So the stiffness equation, F is equal to minus Ks. Should be a minus sign in here. The reason there's a minus sign is because the displacement on an ordinary spring is in the opposite direction of the force. So there's a F is equal to minus Ks. So K is equal to AE over I divided by 1 minus 1 minus 1 times 1 times K is equal to 1 times K is equal to 0.4233, which is pi minus E. And depending on the value of pi that's used, it could be 0.4245, but basically I use 0.4233 as pi minus E, a number that I called Q's modestly in one of my papers. CUZ, Q's for pi minus E, 0.4233, which is equal to 0.8466, which is approximately equal to the sine of 1. But we know that F is equal to minus Ks, so sine 1 is equal to sine theta. The rate of change of K is its derivative, K, is equal to sine times 2 times K prime, which is equal to cos theta. And theta is equal to pi by 4, 45 degrees. So sine of 45 degrees, 1 over the sine of 45 degrees is 0.707, 1 over root 2, which is equal to minus Ks. with a multiplier effect of 7 times. 7 times 0.707 is equal to 1 over 202, which is equal to 1 over y, where y is the dampened cosine curve, which is given by the formula y is equal to e to the power minus t, cosine of 2 pi t. The dampened cosine curve, various economic projects across the economy function on the inverse of the dampened cosine curve. Sales start out slow but build up to a crescendo, fall off and build again, and eventually collapse altogether. Let t equal 1, y equals 0.202. We know that the U.S. economy equation, which we've already developed, y is equal to 0.1358. And since the efficient economy is where y is equal to y prime equals y prime prime, that means the position is equal to velocity is equal to the acceleration. So take the derivative of the dampened cosine, and we have 1 over 0.8534 chi is equal to minus 1 over e to the power minus t cosine of 2 pi t. And this all breaks down to y equals y prime. So the moment times e to the power minus 1 minus the sine of 1 is equal to the e to the moment is equal to 1 over e minus t. The moment is equal to 1 minus the sine of 1, which equals t. F times d, its work, force times distance, is equal to t times ks times s is equal to t times 0.4233, that's k, s squared. Let t equal 1, 0.4233 equals 1 over s squared, s is equal to 1537. So E is equal to the GDP of the U.S. economy is equal to e to the power 0.1358, which is equal to e to the s. So the force is equal to minus ks, the stiffness equation. S is equal to the ln of y. F is equal to k times the ln of y. Sine of 1 is equal to k. Ln of y, k, is equal to ln of y times the sine of 1. K is equal to 118.4, and that is the mass of the periodic table. It's the most mass that the universe can sustain. It gives you the number of elements in the periodic table. And K is equal to M equals F equals M, we're calling it M $sign. So F is equal to Ks, S is equal to 1 because S is equal to time, and time is equal to 1. S is equal to the ln of y equals 1 equals the ln of y, and y is equal to e to the 1, so 2.718 is k. That's equal to the exponential function. K is equal to e to the t equals cosine theta equals sine theta. Theta is equal to 45 degrees. 0.707 is equal to the 1 over root 2. And this all breaks down to the superforce. There's your dampened cosine curve. It starts out, gets higher, and then it drops down. And then it recovers after adjustments are made, and it recovers. And eventually it peters out to nothing. That's your exponential curve. That's in a logarithmic shape. So continuing on with our thesis that economics uses the parameters from astrotheology physics. We have the density, is equal to rho. K equals rho over C. And rho is equal to the dollars per unit, which is equal to 1.27 Q, which is equal to the units. Y is equal to Y dollar sign money is equal to 1.27 Q. Y is equal to E to the 0.1358, which is the U.S. economy equation, and we set that equal to 1.27 Q. 1.27 is 4 by pi, which is equal to the density, 1 over the time. But Q is equal to 1.111, 1 over 9, and we subtract 1.111 from 1, we get 0.888, which approximately equals to C squared, 4233, which is 2.1%. So C squared is equal to K times the change in GDP. So Q is equal to 1 divided by K times the change in GDP. And delta GDP is equal, divided by C is equal to 7. And which is equal to C over K times delta GDP, which is equal to Q times K. So consider the distance equation from mechanics. T minus T is equal to force times distance, but F is equal to minus KS, and D is equal to S. D and S are the same, actually, distance and position. So the distance equation we know from basic physics is equal to VIT plus 1/2 AT squared. And if we take on a sidebar here, we have A is equal to 1/2 AT squared, D squared is equal to 2, and but T is equal to minus T is equal to KS. So D equals S times minus KS. S is equal to S squared K times S cubed. K is equal to 1, which is equal to T. Back to the distance differential equation, S is equal to VIT plus 1/2 AT squared is equal to SC plus 1/2 ST squared times plus 1/2 ST squared, because S and S is equal to V equals A. So we have the golden mean product by x squared minus x minus 1 equals 0. So the golden mean equation is optimized at y is equal to 1/2 k squared minus k minus 1 equals 0. And 2k minus 1, the derivative is equal to 0. That's the derivative. K is 1/2, but k is equal to, from Hooke's law, which we see down here, is equal to sigma equals E. This is the stress, this is the strain, and this is Young's modulus. So this is force over area, which is right there. Strain is delta L over L. So the stiffness E or K, represented by Young's modulus, is equal to F over A divided by delta L over L. K min is equal to 1/2. So if we consider the minimum temperature load for a slender bar of area 1, we have Hooke's law, sigma equals E, F over A equals K times delta L over L. F must be greater than 0.4233 times 1 over 1/2, which is greater than 0.8466. So for a bar of area A, F is equal to 1 over AE, I over AE, F is equal to 1/2 over 1 times 0.4233, which is 118.12, which of course is your mass for your periodic table. 1 over F is 0.8466, which is equal to the sine of 1 radian. So from Pythagoras, we set the mass equal to 0.8466 plus 0.8466 is greater than 118.12. The flexibility for a slender bar, I'm not going to read all those equations off, but it's not that critical. So the conclusion, we see that the stiffness equation from structural engineering can be used to solve for broad parameters of the economy, for example, the US economy. The stiffness coefficient determined from AT mathematics applies for economics as well as for cosmology. That's the central theme of this paper, this talk. Knowledge of this solution provides an algorithm for computer solution to project important economic parameters to help manage the economy for a nation or even the world. So the basic message is that structural mechanics can be used in economics, and there's things we can get from structural engineering that can help predict economic variables. So our next paper is called the stiffness equation and inflation. We consider the stiffness equation from the structural engineering mechanics to show that the capitalization rate is simply the rate of inflation. Continuing in the line of using structural mechanics to solve economic problems, we present here the use of the stiffness equation to determine the optimum capitalization rate or the risk-free rate. It turns out simply to be inflation. The familiar AT mathematics is used to prove this. It is important because some things that can be measured in physics cannot be measured in economics and vice versa. We begin with the stiffness equation. The stiffness equation is F is equal to minus Ks, where S is equal to force, which is money in economics. K is equal to stiffness, the slope of the stress-strain curve. S is equal to displacement, or GDP growth. The stiffness is given by K is equal to F over A divided by delta L over L. That's Hooke's law. 1 over L times delta L times delta GDP. Delta L over L equals delta GDP is equal to E naught is equal to delta Y. Delta L over L equals delta Y. Delta Y over delta L equals 1 over L. So Y prime is equal to delta Y over delta X is equal to 1 over X. So if Y prime is equal to 1 over X, Y is equal to ln X. So we know that the Cusick US economy equation, Y is equal to 0.1358. Ln of X is equal to E to the 0.1358. X is equal to 0.1358. Where Y is equal to E to the X, Y is equal to E to the X equals ln of X when Y equals Y prime. Take the derivative of E equals 1 over X. X, E to the X equals 1. X is equal to 0 or 1. This is where the ln function crosses the y-axis, therefore y equals 0, or energy is 0. So the dampened cosine curve we've seen before, y is equal to e to the minus t cos, the 2 pi t, set it equal to 0, and t is equal to 1, and 2 pi t equals pi by 2, 2t equals a half, t is equal to a quarter, let t equal 1, 2 pi t equals 0, x is equal to 0.1592. That's the moment, which is equal to 1 minus the sine of 1. That's a very important number. 1592 is equal to the moment, which is equal to 1 minus the sine of 1. So y is equal to e to the x, which is equal to ln of x. So we show that x is equal to the moment. So ln of 1 minus the sine of 1 is equal to 1.8418, which is equal to 1 plus the sine of 1. This all breaks down that x is equal to 1. So from real estate economics, we know that the market value is equal to the net operating income of a building divided by the capitalization rate. So where MV is equal to market value, NOI is net operating cash flow, GDP or income. CR is the capitalization rate, the risk-free rate. So the capitalization rate is equal to net operating income divided by market value, which is equal to the gross domestic product divided by the sum of the money The sum of the money is equal to y over CR, capitalization rate. Take the integral, we have money is equal to y prime over the capitalization rate. And we have that y equals y prime, so the market value is equal to GDP divided by inflation. And I'm sorry, I can't read the bottom of that. There it is. Inflation is equal to 1.126, which is equal to the density from AT Math. But we know that the potential energy is equal to E equals mc squared, Einstein's equation from physics. C squared is equal to E over m is equal to E to the 0.1358 divided by inflation. The money is equal to inflation, therefore. And we have the damping cosine equation again. And it breaks down to that capitalization rate is equal to inflation. So we see that the stiffness method combined with our knowledge of AT Math allows for the solution of the capitalization rate. This should be the final paper in the series of mechanics to solve outstanding economic problems. Well, it's not the final paper. So our next paper is called Optimization of the GDP Equation. Economists are now using engineering mechanics to solve economic problems. In this paper, we use astrotheology mathematics to optimize the GDP equation. This econophysics can be used to build it can be used to program a computer to create a real-time computer program to solve unknown variables such as consumption in the broad economy. In a previous paper in a book entitled Physical Economics, I considered making use of engineering structural mechanics model the economy. Different characteristics such as the load on a simply supported beam can be thought of economically in the distribution of wealth across the economy. This deflection of the beam can be considered as the GDP growth. In a series of papers, I considered the solution to these standards engineering programs in a successful attempt to model the economy. For the typos. Things in economics can be measured in physics, and vice versa. Here we consider the well-known GDP equation and its optimization. We make use of the fact that from physics, such as the number of elements in the periodic table of the elements to calculate Y. We make use of the previous paper by this author, QS economy equation to solve the optimization problem so that the ideal level of government spending, consumption, saving, and investment can be determined algebraically. This could be programmed in a computer program which is in another paper, which we'll discuss later. So there's your basic GDP equation. Y is equal to C plus G plus I plus S minus exports minus imports. So consumption plus government spending plus investments plus savings plus exports minus imports is equal to the Y, where your Y is your GDP. The GDP, consumption, government spending, foreign investment, savings, exports, and imports. So we know the Cusick U.S. economy equation is E equals e to the power 1.1315, which is equal to 1.114.05. That's the Cusick U.S. economy equation. As we know from astrotheology mathematics, y equals 1 over y, because y equals y prime. Y squared is equal to 1. So when y is equal to 100%, the whole global GDP, y is equal to that GDP equation. So we plug the 1.1405 into the GDP equation, and we get the number of elements in the periodic table, 117. And so from permittivity in physics, permittivity is given by the symbol epsilon naught is times epsilon r is equal to 1 plus chi epsilon naught 4 epsilon r divided by 1 plus chi is equal to 1, which is equal to 1 over m, where epsilon is equal to strain, m is equal to mass, and x is equal to 0.9915. So epsilon naught is equal to divided by 0.9915 is equal to c squared, which is equal to 100% equals m times 1 plus c squared. GDP is equal to 116, which is your mass, times 1 plus 8.9. Y is 23.4, which is equal to the ln of pi. That ln of pi comes back from that first figure we showed you at the beginning of the talk, where when time is equal to pi is a critical point. 1 over q's is equal to 1 over pi minus e equals 1 over k. K is the stiffness of an individual consumer, the slope of the supply curve. Y equals e to the power t. This is the optimum GDP condition when t equals pi. Y equals e to the pi is equal to c plus g plus I plus s plus 0. We assume exports and imports are 0. The exports equal imports, but we assume to simplify things. So we have e to the pi is equal to c plus g plus a seventh. Your savings is a seventh is optimum. So c equals g equals 22.8. So when your consumption minus 17% is equal to 22.8 times the consumption 1 over root 3, 0.5774. Consumption is 54.47%. So your consumption is equal to cotangent of 60 degrees. That's the optimum consumption. Doesn't matter what you consume as long as you save 15%. And there's your density again, equal to 1.2618 density of the ether. So we see that the knowledge of physical parameters can be used to determine optimum levels for the GDP equation. Someone may program this into a computer program to produce a model of the national or even global economy. So it is well known to economists that engineering mechanics or structural engineering techniques can be used to solve outstanding economic problems. In particular, the matrix method of structural engineering, which is useful here. We can use this method to model an economy from the individual consumer to the contributor to a nation's GDP, and in fact the whole global economy. In this part, I provide the calculations involved in developing a computer algorithm to this end. We begin with the U.S. economy. So the market value is equal to the real estate. In real estate, is equal to the market value divided by the net. Market value is equal to the net operating income divided by the capitalization rate. For the U.S. economy, market value we'll say is equal to M dollars. For the U.S. economy, $2 trillion divided by 2% is equal to 1 times 10 to the 14th. The optimum population density is 3. We know the optimum population density is 300 people per square kilometer, which was determined in a previous paper not talked about here. So the density is equal to the mass over the volume times 1 times 10 to the 14th divided by 3, which is equal to 0.3333, 1/3, equals 1 over c. But we know that E equals mc squared from Einstein. So E over c squared equals m. 1 over 32 equals m equals 1 over 9 equals 0.111. The GDP equation, which we already talked about in previous papers, is Y is equal to consumption plus investment plus government spending plus savings plus exports minus imports. We know from AT math that Y equals Y prime is the optimum solution. That I is foreign investment, by the way. And the money dollar sign, which up here we know is market value, is equal to Y. So the market value is equal to e to the minus t. Market value is equal to 1 over 2.718 when t is equal to 1, which is the beginning of the optimum condition, which is equal to 1 over c to the third, which is equal to 1 over c times 1 over c squared equals market value times E over C squared equals M dollars times 2, which all works out to be 100%. Continuing Y equals Y prime, GDP is equal to market value, which is equal to 1 over E. The dampened cosine curve is given by the equation Y equals E to the minus 1 or E to the minus T, cosine of 2 pi T divided by E. E is equal to E to the minus T cos 2 pi T. 1 is equal to cosine of 2 pi T. T is equal to 1. But E is equal to 1 over T equals E equals 1 equals T. Energy equals 1 over time. E and T are both 1. So we have the superforce, F equals ma. Superforce is 8/3 is equal to m times 0.8415. The m is equal to pi, which is equal to t at the optimum condition, which is 31 over pi. It's equal to 31.8. Energy is equal to the work times the time. And then we have force times dt. Force times dt equals 1 over pi. 8/3 times d times 1. This all works out to give us the Reynolds number. If we take the integral of the frequency is equal to the integral of the mass times the integral of the frequency equals mass times ln of t. And we end up with our GDP equation. So we know from structural engineering, we know that F is equal to Kx, and we've been through all that. I'm not going to go through that again. And then we have our golden mean parabola, which we've already discussed. And K is equal to pi minus E to the 1, which is equal to Q's, 0.4233, that's your stiffness. Then we have the golden mean parabola, Y with Y prime, so we have T squared minus T minus 1 equals 2T minus 1. T is equal to 1/2. So we have, for the U.S. economy equation, we have force over the area, that's stress, is equal to delta L over L, which is equal to strain. And of course for Hooke's law, put the factor of the stiffness factor K in there. So we have a $2 trillion economy divided by 4%, A is equal to a half. So that's your minimum when A is a half, or T is a half, is the minimum of the Goldini parabola. And if you put a half into T squared minus T minus 1, you get E equals minus 1.25. Minimum. A minimum, or maybe a minimum, I suppose. So the individual GDP contributor is this, we just use the small figures here. M dollar equals Y equals C plus I plus G plus S plus lending minus borrowing. So in this paper we provide an algorithm for the entire economy from a nation's GDP to the individual's transactions with the availability of structural engineering matrix structural analysis, it's well computerized. Coupled with a knowledge of the optimum spending levels, economists can monitor and adjust the risk-free rate to optimize the overall performance of the global economy. The next stage is to write a computer program to compute these parameters so that the superior evaluation can be had. So continuing on, second to last paper is the economic vector space and the economic cycle. A vector space is a series of vectors of different magnitudes and direction which are connected head to tail. There is a vector space that applies to the U.S. economy, for example. My previous paper on the Cusick U.S. economy equation contains 11 variables, with the 12th one being time, t. In this, I illustrate here the vector space for the economy as opposed to the physical universe. I've written a previous paper, as I mentioned, on Cusick's physical economy. So mass is equal to 1 over 81, which is 1 over c to the fourth, which happens to be the number 0.012345679. And each successive digit is adding 1 less power of 10. So from logic, a binomial tree yields 1 plus t to the 11 equals e to the 0 plus e to the 1 plus e to the 1 plus e to the 1, 11 times, which is equal to 1/7 plus 7e to the t, which is equal to 1 over 81. So 0.012345679 minus the 7th is equal to 396. That number pops up a lot in astrotheology. Approximately 4. The determinant is 4 and the mass is 4. The plot above is 396 by 396, and then 396 times 396 plus 396 plus 396 is 4 times 396 is equal to 1584. The 1584 is equal to 1 minus the sine of 1, which is the moment. And the cross product is the energy times the time times the cosine of 60 degrees. So E is equal to T. E 2 times a half is equal to G is equal to 0. So there's a gravitational equivalent in the economy. From Newton, we know that F is equal to G m1 m2 divided by r squared. So the force is equal to 2.67 times 8 over 2. I'm sorry, I can't read this here. I don't know what happened to the computer program, but anyway. Our period is 253, 251, and our R value is 0.306, which is approximately equal to 1 3/4. The economy is like a pendulum ranging between high and low outputs. X is equal to 1 over x minus 1 is x squared minus x minus 1, which is solved by x is equal to the golden mean, 1.618. Yeah, that's your golden mean. That's where it comes from, this formula. X is equal to 1 over x minus 1. There's your golden mean probably x squared minus x minus 1. The eigenvalue is the speed of light 3. The eigenvector is equal to root 3. The eigenvector is equal to the eigenvalue times 2. So F is equal to GEC times M1 M2 over R squared. So that's 253. There's that symbol again. I'm sorry, I don't know what it is. G, I guess. D is equal to the eigenvalue. Money is stored energy. Energy cannot be created or destroyed. Money cannot be destroyed. Governments cannot create money. They simply devalue the currency by printing money. From the vector space, we know the economy has a resistance R, which is the cost of producing output, where R is equal to dr by dt. Net present value equals 0, y equals y prime, r equals r prime. Integrate r squared over 2 equals r over r equals 0, 1/2 dr by dt equals pi. E over t pi equals divided by 2 pi equals 1/2 equals r. When e equals pi, a is equal to pi r squared. A prime is equal to 2 pi r, circle 2 pi r times a prime is equal to the circle times r squared, which is equal to a over pi. R is equal to the square of a divided by the square root of pi. It occurs when t is equal to 45 degrees. The economy seeks the minimum energy to produce the maximum sustainable output. So Y, GDP is equal to work. E is energy, and work, and the time is 1, so energy is equal to the work. Recall that money is stored work, so economists use the same laws as the laws of the universe. So from boom to stagnation, we have 4.18 years. Let's draw that from up. So in conclusion, the mathematics model of physics can be used to solve outstanding economic problems. So this is the final paper. More on the 7-year economic cycle and the Bell normal curve. Here is the paper on mathematical economics that provides a solution to the old question as to why the economy goes through a 7-year cycle. The answer lies in astrotheology mathematical physics. The Bell normal curve is used to explain this phenomena. The viscous forces in the economy, whatever they may be, must be overcome by the inertial forces. Further study of the forces should be undertaken so that the negative impact of the cycle can be overcome. In a previous paper, I showed that the root cause for this phenomenon is demographics and the fertility of women. Having children necessitates spending. In this paper, we look at its equation, apply mathematics from astrotheology physics to try to understand why it takes 7 years to come to resolution of a recession. The answer lies in the inertial forces overcome the viscous forces as found in the Reynolds number. We begin with the Bell normal curve. The equation for the Bell normal curve is phi is equal to 1 over 2 pi times the integral of e to the power minus t squared over 2. Take the derivative, and we have that one cycle is 7 years. So the Reynolds number is the inertial forces over the viscous forces, which is equal to rho v, which is equal to the density times the velocity times Poisson's ratio. We know from astrotheology physics that Reynolds number is 403. Reynolds number is equal to the density, which is 0.127 or 4 over pi, times the sine of 1 divided by should be 0.26 for the Poisson's ratio, which is equal to 1 over 25 is equal to 1 over 8 pi, which is equal to 1 over the period. Since 1 radian is 40% of a cycle, 0.4, and Reynolds number is 0.43, then it's equal to 1. Viscous forces in the economy are equal to the initial forces of the boom. So there we have two bell normal curves. You go from boom, you have a decline, a recession, recovery, back to boom, and the cycle goes through again, moving that way. So the Reynolds number is the Niss's forces over the viscous forces. The density is the mass over the volume. And the Poisson's ratio should be 0.26. And V equals A is equal to 0.8415 is equal to sine of 1. So the energy in the economy when the Reynolds number is 1, or the viscous over inertial is 1, is at T is equal to 6 times sigma, which is equal to 7 years. Now the savings is equal to the investment, is equal to 14.29%, which is a seventh. And that's when you have the optimum economy. So an economic cycle is about 7 years. So we see the Bell normal curve adequately explains why the economy takes 7 years to complete one economic cycle. Admittedly, the economy is very complex and other factors that influence its duration. And there are the references for papers I've written on this. If you want more detail and you want to peruse it, then there's some references here for you. I'll leave those on the screen. So thank you very much for listening. I know economics and physics is very interesting to listen to, but I hope we've learned something together. Anyway, thank you very much for listening.